Hello, everyone, and welcome back to a session that I was really looking forward to. A lot of our speakers have given us very practical examples. It was definitely not academic or super duper theoretical, but now we're going to hear from the horse's mouth, so to speak. No offense, Dan, but working in an actual big organization. So we've got our next speaker, Daniel Wertheimer, who is going to talk us through a case study of AI enablement through open source at Absa. Daniel, thank you so much, and we look forward to hearing you speak.
Awesome. Thanks, Johan. Cool. Hi, everyone. So yeah, I'll be taking you through a very real walkthrough of what we're doing at Absa in terms of how we're delivering data science and machine learning models at scale throughout the bank. Firstly, I think the question is, who am I? So my name is Daniel Wertheimer. I'm a data scientist at Absa. I've been here at Absa for about, let's see if I can paste that into there. I've been at Absa for about 3.5 years. And I work within the Chief Technology Office, and my role within the bank is to kind of enable data scientists by providing tools and guidance in terms of how to build them, and I kind of build these myself as well. So I think the first thing I'm going to start off with in terms of data science and machine learning, specifically within the industry, is that there's a difference between what we're taught in academia and what data science is within the industry. And what I mean by that is that in academia, we're worried about things like how accurate our model is, or how much energy our models, a little bit of accuracy so that you can publish this paper that says that you now have something state of the art, and that's kind of where it ends, right? And that process is, it can take anywhere between 3 months, 6 months to 5 years if you're doing a PhD. Whereas in a business, your job doesn't stop where the model accuracy is. It extends further to where you can actually derive value from the models that you're using. And to do this, you need to put them into production. And if your models are taking 5 years to put into production, you're going to have some very unhappy business stakeholders. So ultimately what happens is that you as a data scientist coming into a big organization care about, you only really know about model validation, whereas the business doesn't care about how accurate your model is. Ultimately, what they care about is how much value they can extract from that model. And the only way that's going to happen is if we put it into production. So the next question is, what do we mean by production, right? So this is something that I just put together specifically against what we're determining production. So automated end-to-end, affecting end users. We have strategies for model retraining, model monitoring, and result tracking, and you can extract measurable value from it. Now, something that you're going to hear me say a lot during this talk is keep data scientists doing data science. And what do I mean by keeping data scientists doing data science? Again, as I mentioned, in academia, we're usually taught things like Python or R and model stuff. But when it comes to moving over to production, for example, there's a lot of engineering that comes in. There's a lot of technical jargon around things like the database connections that you're connecting to, deployments onto Kubernetes, for example. These are all things that we're not taught, and while they are, there's copious amounts of resources for this, they're not tools that data scientists are familiar with using. So it takes them time to deliver these things into production. Now, again, you can kind of argue that DevOps teams and engineering teams in agile worlds can work together with data scientists to deliver this entire end-to-end thing. But why can't we also enable our data scientists, and it's something that's considered normal. Data scientists must put their models into production, but why can't we enable them better with kind of open source tooling? So the first thing that I'm going to talk about is exactly kind of some of our problems here, and I'm going to specifically talk about the batch world because we also have a real-time world, but that's actually a little bit easier to manage, believe it or not. Our problem in the batch world is that we've got all these heterogeneous systems with various different OLAs and SLAs, and some data is coming in daily, some is coming in weekly, monthly. There's different formats. You've got Parquet, you've got Mongo databases, you've got Postgres or SQL databases, Oracle, whatever it is. And then there's also this one-way data flow. So managing this and getting this into a data science environment is really kind of difficult. And this is something that we really struggled with, especially because Absa's this amalgamation of banks, and banks in general have a lot of legacy. We still need to work around this, right? So the question is, how do we coordinate this? How do we coordinate when things should come into our environment if we want to automate it? Sorry, lost my words. So how do we, if data is late, for example, what do we do? Do we know if it's late? And let's say if data isn't late, but it's partially there, how do we know that it's partially loaded? These are all questions that data engineers will ask and data scientists care very little about. But when it comes to production, it's very important. And the answer to that is SyncWatcher. So this is a tool that we built internally. It's not open source at the moment. And the whole point of SyncWatcher is to manage these dependencies for us. And the way that it's done this is it's entirely configuration driven. So you kind of configure some JSON, which looks like this. And it's very easy to see what each thing does. And what benefits you get from this? SyncWatcher, what's special about is that it has some kind of bookkeeping technology on the back end. So it keeps track of input and output record counts, when data came in, when it's supposed to come in, and all these things that you would need to know if you wanted to do things like monitoring of whether or not your data is complete, for example. On top of this, SyncWatcher allows job scheduling, and it allows job scheduling based on upstream dependencies. So for example, let's say you have batch models that run daily, but your data has come in 8 hours after you expected it to. Now, in a normal world where you were using something like cron, I hope we're not using cron, your job would kick off at 11 o'clock in the morning, whether there was data or not. With SyncWatcher, you can list any number of upstream dependencies, and once those have all landed, it will then kick off any downstream jobs. And again, we have support for multiple data sources. So we have support for normal SQL, we have support for Hive or Hadoop, we have support for streaming data even. And the whole point of SyncWatcher, again, is to keep data scientists doing data science. And again, this is soon going to be available on Absa's open source software. So now we have this SyncWatcher tool to allow us to get our data into our data science environment. But what happens inside of the data science environment? And again, this comes back to the idea of, there's a difference between what data scientists need for production and what data scientists need for experimentation. As an example, for experimentation, the de facto tool for data scientists to use are Jupyter notebooks. But contrary to what somewhere like Netflix might think, and I know that might be a little bit controversial because they built a tool to orchestrate notebooks. We believe in Absa that there should be no Jupyter notebooks in production. The reason being is that it's really hard to write tests for your Jupyter notebooks. So if you are as a software developer and you want to write unit tests, we don't want to write unit tests in our Jupyter notebooks because that's probably not going to work. If something goes wrong, we don't know when. If we need to refactor our code, we don't know what the problem is. And if we need to, change our model, we have nothing to compare it against. So what is inside our data science environment? And I feel like it's not a tech presentation if I don't show you what we've got going on. So in terms of what we're using, in production, we're using things like the Elk stack, we're using things like Docker, Fast API. Our main programming languages, again, Python and Scala, with Spark on top of those for big data processing. Again, Hadoop, Kafka, MongoDB, etc. And then on the experimentation side, it's very similar, but we use MLflow for our that environment. And now we've got kind of all these tools, and this is kind of like still very much in the normal realm, apart from SyncWatcher, of what data scientists use, right? The problem that we have though is, how do we do this kind of this backwards, where we need to get our data back from our data science environments onto strategic platforms, let's say like Hadoop and Kafka? And the answer is, and I'm plugging it here again, is Absa open source. And why did we develop all these open source tools? Is so that we can keep data scientists doing data science. So one of the things that we look at doing is, how do we support real-time streaming on Kafka? And if anybody has tried to build Kafka producers or consumers in Python, so basically the kind of applications that you would use to get data from real-time services or put data onto real-time services, you would know that this takes about 300 to 1,000 lines of code just to do that bit, with tests, etc. So how do we do that? We open sourced something called Py2K, which is a very high-level Python to Kafka streaming service. It is in its infancy, but it is working, and its producer is production ready. But what is the real benefit of this? We took those 300 to 1,000 lines of code and reduced it into just 5. In fact, it's actually less. So this is what it should be. And what's even kind of better about this specific package is that there's a tool called Pandas, which data scientists use. It's kind of like this is sacrilegious, but it's the Pandas is to data scientists as what Excel is to most people in the business. It is kind of what everyone uses, and you can take a Pandas data frame and just put it onto Kafka in 5 lines of code. That easy. And then the question was, how do we get that persistent storage? Well, like Hadoop, how do we take stuff from Kafka to do that, for example? And for that, well, not us specifically, but some of the data engineers in our team built something called Hyperdrive, which is, again, it's a user interface driven pipeline management tool for Kafka to Spark, which solves a very interesting use case of if we need to access historic information in batch, or we want to kind of offload all of our legacy systems onto real time. How do we store that in a really fast way? Hyperdrive is kind of the answer, and it's built on top of Spark. It's connected to a Hadoop cluster. Again, Absa open source software. That's where you can find everything. And there's a lot more there. We've got tools like Abris, which is kind of like Pi2K but for Spark. We've got a Kubernetes global load balancer, which is something that hasn't actually been developed by Kubernetes. That's been done. So there's a lot of good value there, and we're continuously putting stuff out. I see I'm running out of time, but we are close to finished. This is my last slide. So the question is, what's next? And we now run fully automated end-to-end pipelines of machine learning models that are tracked and monitored, and we have logging around it in the form of the ELK stack. But the one thing that we don't have just yet is automated deployments. What I mean by this is that our code kind of sits in like a GitHub repo, for example, and we have to manually clone it into our environment every time something changes. Again, in the cases of our algorithms that are using, our code bases that are using Docker, this isn't the case, but there's still that git clone step within the Docker containers. How do we get around this? Well, we can use things like GitHub Actions or Jenkins, but even better than that, we're going to do it in the cloud. And the way that we're going to do this is with a tool called Subatomic, which if you follow our CTO, Andy Baker, he said that we're going to be open sourcing parts of it soon, but the entire architecture is up on his LinkedIn. And the whole idea here is that, again, to keep data scientists doing data science, we're going to provision dev UAT and prod servers on a platform agnostic base through a UI, and it's linked to your GitHub repositories, etc., which is absolutely amazing. We've used it on premise, and we're going to the cloud with it. And what's amazing about it is that it's platform agnostic. So whether you're using some kind of Kubernetes stack or Rancher, or you take it to AWS, GCP, or Azure, your data scientists know nothing. They just interact with the GUI. And that's it from me. I do open any questions. Here, I think we may have a bit of time. But if you want to reach out to me, if you're interested in anything that we're doing, if you're interested in contributing to our open source software or even using it, please reach out. We're always happy to have people contribute. Yeah, thank you.
Thank you so much, Daniel. That was very interesting. Awesome stuff and tools that you are using there. We're going to take a very short break because of time, and we go to our next two and final presentations. Thank you so much.